Hello, everybody, and welcome to the Open Mainframe Project's monthly webinar. Today, we have GenevaERS as our project we're going to highlight. Kip Twitchell and Sandy Peresie will be your hosts today. If you have any questions throughout the presentation, please feel free to type those in the message box. We will take those as they come in. And with that, I will hand it over to Kip and Sandy. Welcome, Kip and Sandy.
Thank you.
Thanks, Chris. Appreciate the opportunity to present today. Sandy, how about if we thought we'd just kind of have a conversation in front of you, and we're happy to have you join in the conversation as well if you have questions, as Chris said. We're part of the Open Mainframe Project, one of the newer incubation projects approved in July, GenevaERS. Today, we'd hope to give you a little bit of a sense of GenevaERS, what it does, why it's important, and how it can be useful. But I think also we kind of like to go broader. Sandy is working, I'm the chair of the technical steering committee for the project, and Sandy is our integration architect, has been working across the broad set of open source on the mainframe. So we kind of want to go, I think, discuss a little bit broader the implications for the Open Mainframe Project and how GenevaERS fits into that. Sandy, does that sound good?
That sounds perfect to me.
Do you want to give them a little bit of your background, Sandy, and then I'll do a little bit of mine?
Sure. Well, I'm a solution architect with over 20 years of experience in the mainframe, 15 of which were using this tool before it became open source in a financial ledger and reporting application. Its use of multi-threading and join logic makes it incredibly fast and versatile with the reliability of the mainframe. I really enjoyed working with the tool, and I'm excited for it to become open source.
Thanks, Sandy. So my experience base, I've actually worked on GenevaERS for almost 3 decades now. Been associated with it on and off in various kinds of projects. I have a consulting background. I started my career with PricewaterhouseCoopers and came into IBM as IBM acquired the consulting practice from PricewaterhouseCoopers. GenevaERS started and solved a lot of problems for different customers. We'll talk through some of those today in the financial reporting space. And we recently decided to make it an open source project because open source is changing the world and where the systems on Z are going. I thought today that I'd actually go back and use a couple of legacy presentations. Let me share with you just real briefly here. On the GenevaERS website, our GenevaERS.org, we actually have a section where we've built a museum, and we've put out there a number of presentations that we have built over decades now about GenevaERS, internal documentation, some legacy documentation, lots of material here. I think it's kind of interesting, actually, if somebody were interested in the history of computing and enterprise applications, financial systems, analytical applications, you can learn a lot about how they've evolved in the last 3 decades through our museum here on the GenevaERS.org site. Today, I thought maybe we would use one of those historical presentations just to give you an introduction to the tool. One thing that I'd like to make clear, that GenevaERS, the name GenevaERS, the product started as that in 1992. When it came into IBM for a little while, we changed the name to Scalable Architecture for Financial Reporting, SAFR. The SAFR name we have retained for particular uses when you want to get a zip-enabled version of SAFR from IBM. That's available to you as under the SAFR name, but the open source project is GenevaERS. So in some of these presentations, you'll see both the SAFR name and GenevaERS. They're referring to the same thing, same functionality of the tooling. So let's kind of talk about kind of where SAFR really sits in terms, and Geneva sits in terms of what its specialty is. GenevaERS is it really exploits Z, and by Z we mean ZOS specifically, the flagship operating system on the IBM mainframe. And its really claim to fame is its scale, its performance characteristics, being able to scan very large amounts of data and produce multiple outputs in one pass through the database. You can see here, for example, one of our customers that uses GenevaERS, they're scanning, they're doing things like 19 billion joins in a GenevaERS process. They're doing, they're scanning billions of rows of data and producing millions of outputs from one pass through the database, and doing that within, utilizing a complete mainframe very thoroughly for the entire process. Sandy, do you want to talk about a global bank and how they have used and what the implications are? More also, not just technically, but also the business implications of what the system does for them.
Well, I think from a global bank perspective, you could you could use this in a financial perspective. From a financial perspective, I saw a link on LinkedIn that said a company was very excited to go from their closing from 15 days to 5 days. In the application that for the bank, they were able to have a financial close every day if they wanted to, and that's an exciting thing to happen. This system was a ledger system, okay, not only at the general ledger level, but also at the detail level, the actual all the information that was pertinent to financial decisions and to other decisions that had to be made within the arena that this executed in. It was very quick. You can see some of the statistics there. I think one of the things that's important to know is that the lookups are actually, the joins are actually optimized, where if the first record looked up to that join already, it wouldn't do it again. It would already have the information. So it's very, very quick. It's very amazing product to use.
Thanks, Sandy. Let me add to that just a little bit. I don't know what our audience may come from a diverse background, but just talking about what a closing process is. There's an interesting intersection, I think, in GenevaERS world, where Geneva sits between analytical processes and transaction processing and enables analytical processes for large organizations. A closing process in financial processes typically is preparing everything to produce analytics off of it, and it's making balances, it's confirming that the database is in the right structure, both from a technical perspective and a business perspective. And GenevaERS does that process against the ledgers and can do it against very detailed data. One of the keys, if we talked about what does GenevaERS do, the kind of functions that it does is it scans a database, it does filtering, does calculating, sorting, summarizing, reformatting, and as Sandy said, joins to other files or other tables. And this one's the one that really is tricky in most analytical processes to be able to do that very efficiently. So what defines something to be big? Well, something that's in a Geneva world, big can be either a lot of reports, a lot of processes, a lot of data, or a lot of joins, right? And so when you run the GenevaERS process, Geneva wants to resolve all sorts of queries or processes, produce many outputs in one pass through the file. Now, it doesn't have to be defined, doesn't have to be configured to do that. You could set up GenevaERS and give every user the ability to click execute, and they could all run their own processes. And Geneva's efficiency at scanning the database will make resolving those queries more efficient than you would do in many other tools. But what really becomes efficient is when you say, hey, we're going to resolve all of these in one pass through a particular database. And that process then allows Sapphire or Geneva to leverage the I/O and the join processes, as Sandy said, and many different things that come together in those processes and those queries together. So GenevaERS is really optimized for a large workload when you have scanning processes that take a long time. Sandy, when does GenevaERS typically get executed for the customer that you were working with the tool? What was kind of the times when it would be used at time of the day, and how was it scheduled and used that way?
Yeah, most of the processes were processes that executed in the very wee hours of the morning. Because it was a ledger system, all of the normal transactions, the events that happened during the day, would get accumulated into processes that executed throughout the evening or throughout the wee hours of the morning, using the mainframe when it's not actually very busy, which is very, very efficient cost-wise. So a lot of the millions of transactions would come in and throughout the evening, and they would be batched up and they would be executed, and by 5 or 6 o'clock in the morning, the system would be ready for the user to then look at all their reporting and their analytical and do their analytical processes on the data that actually came in from the previous day.
Yeah, so and it's great, Sandy. So and let's say kind of why that is. Well, here's how the world works, right? Is that when you get to analytical processes, you need to know the population of what you're scanning within that analytical time frame, right? And so going after an analytical process, you kind of have to wait till all the transactions are captured that are going to be important for you to analyze in some way. Well, in most of our world, that happens is because the sun rotates, the earth rotates around the sun. Sorry, I didn't mean to change the world of cosmetology on us. The earth rotates around the sun and it rotates on its axis. So every night, the transaction volumes slow down in a particular geography. And we then organize the database ready to do these analytical processes. And so GenevaERS fits right in that space very well of going and producing all of these kinds of processes and outputs through the course of the night is when it typically runs. And it's not that it has to do it just that way. It's that it naturally fits within the business cycle to do things that way.
Right, and that keys into your earlier statement of, pulling all of the things together and optimizing by one pass of the data.
Yes. That's why it has a particular usefulness in that connection from the transaction processing to the analytical processes. But those analytical processes, let's just be clear, right? Analytical processes aren't just about producing a report of some kind. Quite often our analytical processes feed other analytical processes. So, if you assume that the Geneva design principles are assume that you'll process many reports and processes, and so share as much of the processing as you can. Assume that can't get to the screen display here. I can move that for me. Assume that you will be reading high volumes of data, so minimize the number of machine instructions expended on each record, and assume that you'll need to perform many joins or lookups to other files or tables, right? It's mass transportation as opposed to everybody having their own bicycle to get where they need to go quickly. Let's look at just real briefly here, kind of how GenevaERS got developed. It kind of makes the functions fairly clear about how it does this sort of work, right? If you go back decades ago when we were doing projects, analytical kinds of projects, you would often find, if you went on the mainframe where these systems were first automated, you would go out to the system queue to see what was running. You'd find program A, B, and C that all were reading the same set of master data, transaction data, to produce some sort of output. Well, the original inventors of GenevaERS said, you know, if we simply scanned that once and produced all the outputs, then we'd be much more efficient. You would have one pass through the data. So that was the first level of optimization in developing GenevaERS. The next one was recognizing that as you're reading those transaction files, that producing reports, we often have to do joins of some kind. Sometimes those joins and lookups are simple, code description things that have to be done, but quite often there are other types of joins. And so, the inventors of GenevaERS said, if we took and simply, instead of doing keyed access against the table directly in each one of those programs, if we made what's called a core image file, it's a very old processing concept, but we loaded those tables into memory and did high-speed joins against them, we'd be much more efficient and much faster. And that's where you can, like Sandy talked about, you can recognize that you've done a join before and be able to see how you can reuse those join processes for other purposes. Then the last phase of it, in the early development of it, was recognizing that if we could use the power of parallel processing on the machine, and GenevaERS was one of the first parallel processing tools really out there, that you could produce the outputs much faster because we can use the machine capacity to produce outputs much more quickly. So instead of stacking up all of the transaction files and reading them sequentially, we could break up and read each one of those in parallel to produce our output. So through those three kind of major steps, GenevaERS built in its major optimization features. Let me, I don't know, Sandy, let's I think take them through here a little bit more detail of how the performance engine works. There's kind of two parts to GenevaERS, two major components that are maintained in the source code environment. One is the workbench. And here in the top left-hand corner, we have a view and metadata repository. In GenevaERS, we call processes views. They give you views of the transaction data that you want to see. Not like a database view per se, in that it's predefined, but a view in the same sense that it will take and pull out of the data what you're interested in seeing from that data. So we have a small database where we build today processes in the GenevaERS workbench. And you begin by defining metadata to define your record structures. And GenevaERS is a little unique in that not only do we just define the record structures, we also predefine relationships between data structures. We call those paths, join paths. That means that it's like the where clause within a SQL statement. We predefine those, and so when you're building a view, it presents you with all of those relationships that have been predefined, so that you then don't have to go specifying the where clause on every instance of where you want to do a join. You can pick up that predefined where clause to specify the joining part of a where clause specifically, not any of the filtering or something like that. So you define up front those processes that you want and the metadata that needs to go with those, and that gets stored into the metadata repository. The first part of the execution engine is called the select phase. And the select phase is a process that you pass in parameters to what's called the performance engine. This whole bottom part of the screen is what we call the GenevaERS performance engine. That process, you pass in parameters to say, hey, in this execution of the performance engine, which views do we want to resolve? And you can control that based upon what parameters you pass to the performance engine. The performance engine select phase will then select from the metadata repository those views that need to be resolved in that pass through the database. The process of putting those, it builds them into a file that historically has been called the view definition parameter file, the VDP. We do, in fact, have our customers over the years. So we've had 20 plus customers over the years. Some have not wanted to build other ways of executing GenevaERS rather than simply building views. That tends to be a more of a technical user that builds views in the workbench. They had business applications where they wanted to define those kinds of things. Sandy, can you talk a little bit what kind of the unique features of those business applications? Why did your customer, the customer that you worked for, build those? What were those applications like?
The applications that they built was to enable a finance user or a user to actually go in and determine what they actually wanted to do from a reporting perspective. So they were able to, without the workbench, without the knowledge of the technical expertise needed for the workbench, they were able to use business rules and produce reports and extracts and information that they specifically wanted to hear to supply a specific need. So these things were then batched up and executed, you know, in the wee hours of the morning, and they would have their information available when they came in the next day. It was very efficient that way.
Yes. So, and that's your key point there was you wanted to simplify the workbench environment for those kinds of queries for business people to be able to do that. Well, GenevaERS opens that up through a mechanism called VDP, the View Definition Parameter XML API, where you can build another application, another way of defining a SAFR or GenevaERS view, as long as it adheres to the XML standards for GenevaERS. Then this select phase can take that in and it can become part of the GenevaERS process, even though the process was defined outside of GenevaERS. When we talk about where we're going as an open source project, we'll come back to this point here about the workbench and this XML and how we're planning to open up more power for GenevaERS through this process. The next phase of the process for the performance engine is the logic phase. And the logic phase builds what we call logic tables. It really is kind of, you could think of it a little bit as a compile process where we take the language, you know, in a language definition, we break down the view definition into much more detailed steps that have to be actually executed. And so those steps sequentially of saying exactly what has to happen as we pass through the database, we put out into two different logic tables. We're going to be a little bit simplistic in this, just given the time we've got today. There's one logic table that's used to build the core image file for the reference data, but the other logic table then is the one that resolves in the primary scan processing, the extract phase logic table. The key program, the extract engine, single pass parallel processing extract phase, it really is defined in a sense to, it kicks off parallel processing, generates machine code for each one of the files that needs to be passed. So by defining different partitions as your input to the extract phase, we then, GenevaERS will read the logic table. As it reads the logic table, it then has model machine code inside of the GenevaERS execution engine for each one of the functions that has to be performed. And as it reads the logic table, it then builds a program in memory that is machine code, straight to machine code, for what needs to occur as it reads a particular partition and resolves all of those views for that partition. So if you think of the simple little, if you've been around quite a while and have worked on an old ledger system, you might have seen a pattern show up in often reporting applications, which was this pattern that GenevaERS really automates very effectively. The pattern is that you have something that's like a 1,000, the paragraph in your COBOL program, the structure of your COBOL program might be 1,000 initiate processing. Then paragraph 2,000 is, and in 1,000 you open a file that you're going to scan to produce your reports. In 2,000, you read the first record of the file, and you have a loop there in paragraph 2,000 that's read until end of file. And so you loop around that transaction input file that you're reading, and on every one of those records, you do something with those records. And then the program, after you get to the end of the input file and produce the output that you need to of some sort, you have 9,000 terminate processing. That's a very common pattern in ledger-based systems that have a periodic nature to them, because you have to, within the course of the night, you have to process all of the transaction data that's been received through the day and produce all of the kinds of views that people are going to need in the morning to begin business again. That process of reading until end of file, the 2,000 paragraph, in GenevaERS, Geneva does a subparagraph for every one of the views that has to read that particular input file. So 2001, subparagraph 2001 in read until end of file would be process view number 1. And paragraph number 2, 2002 would be process view number 2. And every view that needs to see data from that input file will get to see that data from that input file. And the things that they're doing as they see those records within those subparagraphs, for example, they're filtering, they're calculating, they're sorting, they're summarizing, they're reformatting, and they're joining. Those are the functions that are done within each one of these phases. Let's take a pause there for just a moment. Sandy, anything that you think might be interesting to people as I've gone that far, or something they haven't made clear in that process?
Well, I think if you can think of it as maybe for the financial people out there, when you think of an event transaction coming in a ledger system, you'll want to do view 1 would want to read the transaction and create a couple of journals out of that, debit and credit journals out of that. And then it would want to do maybe conversion on that. And then it would want to do any, eliminations between businesses within the same company. And it would want to create additional entries for possibly GAAP information, US GAAP or UK GAAP. If it's different than IFRS. Now I'm getting a bit financial here, but people that listen to this, and it's important to understand the finances behind something like this. These things would be view 1, view 2, view N, and it's a good example of how one event coming in, one transaction coming in, would produce probably 6 or 7 debits and credits for the system.
Yes, Sandy, that's great. What you've done there, right? You've connected the business application of needing to do these business process, which it's not really just about producing a report. It's about producing new transactions that then sometimes generate additional transactions, which might generate additional transactions. And you can have an explosion of these transactions before you actually get to the reporting phase. But GenevaERS, through this process, can enable all of that to be done in one pass through the database.
That's correct. That's correct. One of the things that is always amazed me also is its good use of memory as well. For the geeks among us, you know, all the reference data is above the line. So it has very efficient memory usage for the process that it's doing as well. In the machine, you know, memory in the machine, it's just very, very well done as far as that's concerned as well.
I want to talk about two other points on here, but I want to come back to that, particularly to compare to other technologies that are kind of in a similar space. But you remind me, Sandy, that I want to point that out. The other point that I want to make here is that these green little balls on this chart are API points in GenevaERS where you can drop out to custom code if there's something that GenevaERS doesn't do. For example, GenevaERS doesn't do statistical calculations. It only does basic arithmetic operations. But you could use this API point here between the view and the high-speed reference data. You could use it and not actually join to high-speed reference data, but simply make it a function call to go do a statistical calculation of some sort. So these API points are make GenevaERS very powerful to put business logic in and to extend GenevaERS to functions that it doesn't do natively, but still get the efficiency of GenevaERS, the efficient infrastructure. The other point that I want to make is this little green box at the bottom here of the extract engine. GenevaERS has piping mechanisms where a view can write out data to be processed and scanned by other views without ever landing on disk. So it's virtual files. That piping process, like a Unix piping process or batch pipes on ZOS, allows us to expand and add new capabilities and more functions that need to be performed. Particularly, you can consolidate if you want to have logic that works across many of the partitions and you want to have that logic contained in a single view, you can pipe from those previous partitions into that subsequent process and perform similar processes. And so entire applications have been built by our customers using GenevaERS as the application platform development environment. The last phase of the process, which tends to get used less frequently, is the format phase. And that's when we have to have, in the MapReduce world, there's something called a shuffle that often happens when the sort order, it becomes important, and perhaps you have to cut across partitions and bring data together from different partitioning schemes and the sort order you need to make. Well, that in GenevaERS is the format phase. In a certain sense, the extract phase is map, and the format phase is the reduce phase. And the reduce phase will then, after the data is landed to disk in the extract files, the sort process is called as an exit to read the data, but instead of writing the data back to disk, it passes it to the format engine, which then does the aggregation, the last phase aggregation, to produce the final outputs for the process. Okay. Sandy, let's go back for just a minute. I just touched there upon MapReduce, right? And one of the more recent developments in the MapReduce world, it's now, what, 5-6 years old, but it's got a lot of interest in it, is Spark, Apache Spark as an engine. To be honest with you, when I became aware of MapReduce and thought about what we had in GenevaERS, GenevaERS's development in the early 90s really predated MapReduce by a full decade. And in a certain sense, it automated the MapReduce process on ZOS using machine code in a very efficient way that leverages ZOS very, very, very powerfully to do functions that are like a Spark function. Any impressions on that, Sandy?
I think when you talk about correct usage of ZOS, it's really built to use memory within the system and not do the I/O, which, as you know, the I/O is probably one of the slowest processes in a program. And because it's able to put everything in memory and actually use the memory efficiently within the ZOS, which is a ton of memory, it runs very, very quickly.
Yes. So that's where I wanted to go, Sandy. See, you look at the speed with which memory processing happens instead of disk processing, memory is just thousands of times faster to access. But so many of the MapReduce functions in the world assume that all the transactional data has to be put into memory before the map or reduce functions will execute. And so what you end up with is this scale issue of you have to break up the file to be across all of the nodes. You have to have more nodes available so that you can partition the file down so that the file ultimately will fit into memory across the entire platform cloud processing environment you're using. You have to put the transaction data into memory in order for the process to function. GenevaERS doesn't require that. GenevaERS, because it recognizes that it can do this windowed process of bringing small amounts of the transactional data into memory and use that transactional data to produce what's needed for the output to begin with, and then dump that transactional data and move on to the next set of transactional data. It uses the memory processes very efficiently. So what you have there is you don't have to have 1,000 different nodes available to you to process against a very large file. And so the ZOS engines become more efficient because we can drive the I/O processes very fast. I/O on ZOS is very efficient. We don't have to put all of the data into memory to process it. We can do this windowed processing with the data in memory. And then we can use the outputs appropriately, produce those outputs in a very efficient pass through the process.
Yeah, you're right, Kip. I had forgotten about the fact that I don't know how I could do that, but I had forgotten about the fact that it's an event type processor where it takes those events, and once you're done with those events, it dumps them right out. So you're using memory even more efficiently than some other systems.
Yes. So all of that is part of the story of GenevaERS. Where we'd like to go, let's give Apache Spark its due here, right? As well as we're looking at the GenevaERS project, and maybe I could go here briefly to the GenevaERS site. We're looking at how we can integrate with the processes of Apache Spark, and how the processes can effectively work with Apache Spark to run against the to make it a more efficient processing engine. And so the process of integrating GenevaERS with Spark is something we want to drive more effectively too. Apache Spark comes to the table with much more effective, much more efficient reduce functions than GenevaERS has. It's much more powerful with its machine learning capabilities and all of the functionality on the reduce phase. But when it comes to the map phase, GenevaERS, I think, is more efficient and has more capabilities than the typical MapReduce or Apache Spark map phase. Because often in the map phase of Apache Spark, all you're doing there is that you're simply breaking up the transaction file based upon the number of nodes that are ultimately going to process that data. Well, GenevaERS, in that map phase, it can be producing hundreds of outputs if the only thing that's needed is to pass the transactional file, if you don't have to do a shuffle process, and it can produce a lot of different outputs in the map phase, which takes those out of the need for being processed in the reduce phase. So I think there's a place here of synergy where you use GenevaERS as the efficient ZOS map phase and connect it to Apache Spark, either Apache Spark off platform if you want to transfer the data off platform, or going to ISOTA, the Apache Spark capabilities on COS, and use all of the power of Apache Spark for the reduce phase. Well, that's a lot of talking there. And I don't think we have any questions so far, so we can keep talking, but I do want to pause and let you know that happy to answer any questions that somebody might have in our webinar. Let me go here, kind of, Sandy, and then I want you to kind of say what comes to your mind as we're working here. You look at the number of customers that have used GenevaERS. A lot of these customers used it early on. Where we worked quite frequently in financial applications was we became involved in often ERP implementations where the ERP systems could not produce the reporting outputs that were required. And so GenevaERS was used to connect the transaction processing that went on in the ERP systems with the analytical outputs that needed to be produced. And we've had a score of customers, various kinds. Early on was state governments. They were some of the first of that had to do enterprise level reporting. State governments were mandated by the federal government to produce enterprise-wide views in the 80s. And so they were one of the first ones that ran into this problem, and GenevaERS got its start from that space. We had one of our major customers for over a decade and more was Sears, used GenevaERS for a lot of different scanning applications. PwC, PricewaterhouseCoopers used it in its education system for reporting processing. ADP Proxy used GenevaERS for more than a decade for its reporting and audit applications. There was a antitrust litigation against pharmaceutical companies in the early 90s. GenevaERS was given dumps from 13 different major international pharmaceutical companies and was used to produce analytical outputs that analyze the data in terms of sales and cost and presented data to the trial in the antitrust lawsuit. Keebler and Kellogg used GenevaERS in conjunction with their sales reporting processes for more than a decade. Would do detailed territory processing. I might say just a moment more about that. One of the key things that the GenevaERS join processing allowed them to reorganize their sales districts in very effective ways and be able to recast history so that as they reorganized sales district and moved customers into different districts and balanced out the workload of different salespeople didn't have their metrics change to all of a sudden, just because the system changed, it shows that they have a very different world from what they historically had. They could do recasting of reclass processing. Sandy, a topic that's near and dear to your heart is the need for that reclass processing. You want to just, we can't go into detail here, but just tell them what reclass processing is and your expertise in that space. Can you do that real quick?
In 15 words or less? Probably not. Basically, if you're processing at a transaction level and you're trying to reconcile back to the original source of the data, when the source changes, okay, you have to accommodate that source change within your application that's downstream of that source change. And what that means is you have to take that source change and move balances or monies, events around to accommodate and reconcile back to say that, now my balance is sitting or my money is sitting over here rather than where it was originally put. Geneva helped that process very, very quickly with that exit that Kip mentioned before, a business exit. within the product, and it's important to have that because you want your money to be where your original source said it's supposed to be, and that was one way of doing it.
Thank you. Sandy has deep expertise in the problem, a very arcane problem called a reclass processing. And we are supposed to put out some more videos about that at some point on my ledgerlearning.com site. I don't know how much more detail to go here on these other customers, but Intel, surprisingly enough, for their ERP system, was a large user for GenevaERS for nearly a decade. We had UBS Bank in the US. United Airlines did a prototype with GenevaERS. So there's a lot of, even IBM used it for a while internally for ticket tracking purposes. So there's a lot of different applications that it has been used on over the time. As the systems have changed and most of those applications were migrated to other things, GenevaERS was migrated out of the picture. But the functionality for high performance for some of our customers, it isn't something that replaces GenevaERS and how it works for those customers.
I think it's important to note there, Kip, and it may be obvious, but it's important to note that all of these places have lots of data.
Yes.
I mean, they're crunching lots and lots of data.
I think in the last couple of minutes, let's talk more about kind of the impact of open source and what it's doing to z/OS and why we're happy to be part of the Open Mainframe Project and where we think open source particularly is going to affect z/OS in the future. We're coming up here on March 15th of next year on the 25th anniversary of one very famous prediction that was the death of the mainframe. This poor individual, Stuart Alsop, happened to make a very prominent prediction that got remembered. He predicted that the last mainframe would be unplugged on March 15th, 1996. Well, March 15th next year is 25 years from that date. And he was off by much more than 25 years because they're in no danger of being unplugged. They're growing in terms of their use. The business applications on them are very important applications, and it's not easy to migrate them off of z/OS because of the nature how Z was developed to handle these financial applications in very effective ways. One thing, though, that's happening, open source is growing, and it has to grow from, it's ultimately going to win. This is Holger Mueller made a great comment about this, about his perception about how open source was ultimately going to win the wars because companies could no longer afford to fund proprietary software development because open source is a lower cost means of developing. But Frank Scavo, in picking up on Holger's comment, he said, listen, open source still hasn't had the major impact in ERP system space because the number of users in an ERP system is smaller for each business function. And for open source to be very effective, you have to have a large number of users to have the community to develop the functionality it needs. I think that's going to change with time. As open source continues to grow, it's going to eat into the ERP space, and it's going to have an increasing impact on ERP, ledger, finance kinds of systems. This is an interesting graphic, though, as you compare open source to proprietary systems. This was 400 professional developers comparing the qualities of those things. And on most aspects of these criteria for developing or looking at system characteristics, open source is clearly winning. But when it comes to reliable support and consulting services, open source typically doesn't win. Well, the thing that's interesting about GenevaERS is GenevaERS comes from a highly supported application environment. our customers are supported very effectively. This is a critical application. And so our customers have to have somebody that they can call in the middle of the night if this doesn't work. So even though we've open sourced GenevaERS, there's a model here where we're going to have people that will be able to be on call. Yes, there's a price for that, but it helps enable these people to be on call and to get in and solve problems quickly in these critical application spaces. This is a space where Z as a platform should be able to perform very well because Z has always been about high availability, high support. So the more we turn our applications into supportable products, we're going to increase the impact of open source performance because we're going to turn that metric around and say open source can have as good of support as proprietary systems. Sandy, any comments there?
Oh, I think it's very exciting that it's becoming open source. I think the more it's used, the better it's going to become. And I think this is a great way for the mainframe to really get revitalized. The open source community is a great community to be involved in, and it's a way to get better and better ideas and innovations into a product. I think this is wonderful for the product itself.
Yes, I think you're right, Sandy. So, and as we kind of looked, right, as the ERP systems begin to be affected by open source, we're going to see bigger and bigger impacts upon the ZOS systems. One of the things, though, that's important to note about this is if you look at just this on the right-hand side here, the complexity of the business processes for many of the later applications that have been developed, like search engines and e-commerce sites and social media sites, the complexity of the basic business processes aren't that complex because they're dealing with transactional systems. But when you look at financial applications don't deal with just today's transactions. Financial systems have to build balances, and balances incorporate what history has done to that same data. So you have this historical aspect on financial applications, and the accuracy required is just very high. I mean, if you had a search engine that, you do a query on a search engine and it drops some set of URLs that it probably should have shown you, are you ever going to know that it dropped those URLs? Well, it would be very difficult to know that it didn't show you URLs. If you have a financial application and it shows you a balance, and that balance doesn't include some set of transactions that either you were supposed to be paid for or something like that, well, people figure that sort of stuff out. It's critical to have the balance be correct. And so the nature of ZOS and its reliability means that it takes away the trying to use redundancy in cloud platforms to overcome native problems of the platform, inherent weaknesses of the platform. ZOS, its reliability, means that it's a space within which these financial applications continue to survive because it's so reliable. So where we think we're going here, Sandy, I guess, we got just a couple minutes left. It seems to me that as I look at the Z Linux side of the mainframe, this is where so much of the open source work has been done. The yet to be done, as Jenny Rometty said, the 80% still to be done to migrate to the cloud, a lot of that sits on ZOS. And what's interesting to me is that the Unix system services and the new ZCX, the Docker environments that run in ZOS, they're going to be the means that pull the innovation that's happening in the open source world and have it start to impact ZOS in a very significant way.
That's correct. And I would add there that even though, I've spent over 20 years on the mainframe, never really gotten involved in open source. And I think it's important to know that even though you're dyed-in-the-wool mainframer, you can be involved in open source. It's very easy to get involved, and it's a great opportunity to have fun with programming and with the process itself.
You know, why don't you go there, Sandy? Talk a bit more about your journey, and then how to get involved, and what we kind of need people to be able to help us do on getting involved in the projects if they want to have fun.
Well, you know, like you said, it's a fun way to get back into, you know, we all have a lot of stress in our jobs, but this is a fun way to get back into to get back into programming where it's fun to do something. What we've put together, one of our contributors has helped put together an onboarding document that anybody can follow. There's screenshots of how to start contributing to the project. You can use this for any project, but we'd love to have you at GenevaERS. It goes step by step how to get involved with GitHub, how to get on the Slack channels, how to you know, get into the Linux Foundation, all of these things, how to get in on the mailing list, and it really, you go through this whole thing. And you're ready to contribute. It's that simple. And we need programmers. We need, you know, people that are good at documentation, people that are good at websites. People, you know, we have all sorts of things that people can get involved with. And I just started with open source less than 3-4 months ago, and I really enjoy what I do with the community. It's a great bunch of people.
And so if you have questions based upon this, Sandy Peresie is great to have conversations with. She's on the Open Mainframe Project Slack channel. If you want to, you know, reach out to the Open Mainframe Project, and she'd love to have a conversation with you. You can find more about us on GenevaERS.org or on the Open Mainframe Project site as well. We think we're at the heart of changing transaction processing systems for financial applications and ledgers, which is really the majority of the work that's left to be done to renew our environments. The mainframe is very relevant to that. Open source is a means by which those applications are going to be changed in a very effective and efficient manner. Community development is key to that. So, you know, if you want to renew and have some excitement in your mainframe development, or if you're new into developing, just graduating, and you want to learn something new that's going to be a growing field, ZOS is a great space to be working in. And for existing developers, open source is something you should be working to become involved with in some way.
Absolutely. Please reach out. I reiterate that. Please reach out to any of us on the Slack channel within Open Mainframe. Love to talk to you. Love to answer any questions you might have, and welcome you to the project.
Thanks, Sandy.
Thank you so much, Sandy. That was super informative. That was a ton of information and a lot of great knowledge there. I want to thank everybody for joining us today. And once again, if you have any questions, feel free to reach out to all the various resources Kip and Sandy shared with us today. Thank you from the Open Mainframe Project. We look forward to seeing you next month. Thank you, Kip. Thank you, Sandy.
Thanks.
Thanks for inviting us.
Bye.
Bye-bye.